Dzień dobry. I've got my entire presentation here. Actually, I thought I should make a few sort of thanks before I start. First of all, I'd like to thank RETENCJAPL because I'm very honoured to be invited again. I was invited last year to give this keynote and I was ill. And it's really nice to actually come here and share a few things with you. Got an awful lot of time and respect for RETENCJAPL. I think in championing what's being done in stormwater in Poland, I think they're doing a fantastic job. And I'd like to thank Jacek Zaleski, who stood in for me last year, and maybe he may have presented the slide you're about to see, so you may be getting it twice. And after the delays last night, I'm surprised that anyone's here in terms of the trains or the flights. In fact, I had so much delay, if I'd known I could have read God's Playground by Norman Davis on the way. I must have been about 4 hours late. Anyway, let's make a start and I'll tell you something about me. I go around the world presenting, and at most conferences people present and you know nothing about them by the time they've left other than the subject they've spoken about. So I'll try and say something about me so you know who I am. I'll then set a wider, I want you to open the context of thinking about stormwater. I want to take a step back to think about cities, about governance, so the way in which we manage across the water cycle, about the water resilience of cities in the wider context of resilience. I'll try and give you some global examples, and I said I'd try and get you some sort of cool digital stuff to get us excited by the time I've finished. So who am I? My background is very much as a geologist and with an interest for the Royal Academy of Engineering in sustainable development. So I'm interested in sort of social, economic, environmental, technical, political, trying to look at things from all directions. But because I'm geotechnical, I'm used to creating frameworks of understanding. That means I'm always trying to make sense of things. And it suits me to think about the water cycle. It very much resonates with my experience. And the most important thing to me, you'd think I'd come out and say, it's stormwater. Well, it isn't. The most important thing to me are my kids. And my connection with my son, we go to the football together, we're Everton season ticket holders, but my connection with my dad, we fish together. And I think I knew from when I once stood on a riverbank, I was going to be involved in water. And that's really important because I'm passionate about water. I'm passionate about something I thought was pretty fixed for a lot of my career, and is much more dynamic. Our climate's changing, and it's really important that we see that what we do within the context of a changing climate. And it's lovely to see so many friends, colleagues, partners, and clients in the audience who share that passion with me. So in terms of cities, it's really important for us to think about, we've passed the point where more people live in cities than live in rural areas in the world. And it isn't just that drive for urbanization, we also see the rise of the megacity. And I'll try and finish off with some digital stuff on a city of over 25 million people, where we're starting to look at things in terms of scale. The other thing is that climate change is costing the world a huge amount, and that's only going to rise significantly. There's a course I run with MIT, and we're seeing hurricanes occurring more frequently and the damage of increasing intensity. There is a real challenge as to whether society can afford that. So cities are really complex. And how do we sort of make sense of them? So I thought I'd share the way I think about it. It's important that when you think about the city, you don't only just think about stormwater in isolation. I think that would be a real mistake. I think we have to broaden the agenda and the context. So I like to think about assets. So that's natural assets, human assets and physical assets. And each of those assets are all part of an asset system. And cities are made up of systems of systems. And maybe I spent 15 years of my career, maybe 20 years even, thinking that this was arranged like this pizza is, where each system was discrete and we could manage the system within our little slice of pizza. And I think that's not how it is in the real world. Maybe I used to think that way. Maybe I had a narrow perspective and I've tried to broaden it. It's a bit more like this, which I'm surprised my tummy's not rumbling because I didn't have that much for breakfast. So it's a bit more really, I think, about systems of systems. And we have to think about systems of systems. And if we're thinking about systems of systems, you've got to remember that each of these systems have interdependencies, so they affect each other. They don't operate in isolation. So a really important thing for us to take away when we think about stormwater is thinking about all those other systems that we interact and interconnect with. I think the other important thing is the scale at which we look at an issue. And we should look very much at a catchment scale, not at the boundary of a city. And the other thing is that cities are subject to a whole range of shocks and stresses, not just stormwater. So you'll find that within this systems of systems thinking, people are looking to try and solve problems that include stormwater, but a whole range of other shocks and stresses. Okay, I'll hold it there for now. And now I'll take a step back. One of the interesting things that I've started working on over about the last 8 years is us really going back to when we first started to manage the water cycle, when we first introduced public health solutions to our cities, and how we manage that water cycle across the whole catchment, not just within what I call metropolitan water. So I was doing some work with the Board of Yorkshire Water where I put a challenge to them to say, you know, how much of the water cycle do you really influence? And this thinking about other systems or other players or other organisations who had a responsibility, and have you really connected with all of those organisations? Now, why is that important? Because if you understand their responsibility across the water cycle and then we flex that cycle, then we can see who are the most important organisations to be working with over different shocks and stresses. So what we did, I'll just take a step back. So this represents a number of those main organisations across the county of Yorkshire that are responsible either for Yorkshire Water, which is supplying clean water and sewage treatment, the Environment Agency, who are an environmental regulator but also look after flooding, a Canal and River Trust who look after canals, an internal drainage board that think about agricultural drainage of water, local authorities who manage drainage within cities, Network Rail who have major assets affected by significant shocks and stresses, Highways Agency, they're the road agency, and then private owners. So the interesting thing is, don't worry about the detail of this. This is basically the water cycle as a flow chart. Consider it sort of a framework on which we're going to hang things. And what we're going to hang is the responsibility of different organisations. So if I was to take the water company, they're not actually responsible for the entire water cycle. They're only responsible for part of it, as are the Environment Agency, the Canal and River Trust, the local authorities, or city authorities, the internal drainage boards. Now, there's a reason for this in Network Rail, because you'll see different parts of the cycle get illuminated, and private owners. So that when we then apply shocks and stresses, we might say, sorry, I missed the Highways Agency off. We might say who does what, and you find that for different elements of the water cycle, there's a number of organisations who are responsible. Now, the water company was not talking to all of these organisations in trying to manage the cycle, and that's why we had problems when we had extremes like the floods of 2007 in Hull. So extremes like too much water, it's either too hot and there's too much water, or it's too cold and there's too much water, or it's too hot and there's too little water, and it's too cold and there's too little water. And we seem to be having extremes in all of those areas. So what that framework does is allow you to start to look at, when these things affect different parts of the water cycle, which the organisations are affected, and have you got the right people in the room to solve it? So if you took nothing away from this presentation today, other than I will think at catchment scale, and I'll make sure I understand who's responsible for what across the water cycle, and then when that water cycle's stressed, who to talk to, then you've moved on significantly. Ironically, when we went to the city of Hull recently, they had 4 organisations in the room. After we mapped their governance, we had 17 organisations they had to engage with. We ran a workshop, and they said that's why certain issues weren't being addressed when we were affected by significant either storms or tidal floods. We've done this now. We have a model. This is Amman in Jordan, where they've just, their shock was having a few refugees arrive from Syria. Their stress was when that drip became about 2.5 million refugees. It doesn't rain anymore, so they've got to manage that situation. We have to manage their shocks and stresses in their own way. And the model that we've now developed to look at governance allows us to then look at the interrelationships and find out where either there aren't discussions taking place or where we should improve the quality of those discussions and who should be in the room. Okay, it's quite nice when I can share some global examples of what's been happening when we suffer extreme storms, the way we sort of respond. And we might respond conceptually by thinking, what could we do at scale? Where can we fit solutions in from a stormwater perspective that might sort of soak some of this water up? And it might be that they can also passively treat. So this idea of something called the bioswale. So in New York, that's what conceptually a bioswale looks like. It soaks water in. It provides green within the city. So it intercepts, it stores, it passively treats. And this is the way in which you might convey that with your citizens. You might share visualizations to say this is what it's going to be like, but would this work, putting 20 or 30 of these into your city? I doubt it very much. You can even see what they look like, so we can build a few and get people on board, but scale's the important thing. It might not work if we put 20 or 30, but maybe it works if we put 6,000 or 7,000. At the moment on Coney Island, I think we're responsible for managing 900 of these going in Coney Island. to help create that sponge in the way in which we talk about sponge cities in China, but the way in which we soak up. Maybe we also have to start thinking differently. Sometimes grey pumps and pipes and storage tanks are the answer. Sometimes they aren't. Sometimes it might be too expensive to provide storage for extreme events that aren't going to happen all the time. Maybe we could work within the public realm and think differently. This is Red Hook in Brooklyn, in New York, and I'll just click through. What we've tried to do is think about where can we make space for water, where can we control where water might flow through the city when we have an extreme. And I bet you didn't think it was going to be to there where I was going to delimit where the water might go. What we do is create flood-proof corridors within the city so we can control where we have overland flow, where it's going to be most extreme, and work with it, try and understand it, rather than work against it. And you then can start to explore at a precinct level what are the things you can do on the building, in the building, and within the space between the buildings. So we go from building scale to campus scale to the point at which we start to use streets to encourage flow. Okay, so that's how we might do it within an existing city where we might introduce things that could soak up water or where we might divert water flows. What about when we have new developments? So this is, it's one of the most ambitious waterfront developments in New York. I can read the slide, there you go. It's Hunters Point South. So what we've tried to do is ensure that the look and feel of the way in which we start to manage stormwater can contribute to a greener and a bluer public realm, to a healthier and a more livable public realm. So this is Hunters Point South, where we have bioswales, we have porous pavements, but we also have our grey infrastructure as well as our tree pits. Now, I'm sure you all can probably present different examples of this in different places. What I'm trying to do is share with you the way in which people have responded at scale within their own context, within their own city context, in other parts of the world. Interestingly, in Philadelphia, what they have is like a GIS-based system where interventions for blue and green interventions that help them manage stormwater, that the public are involved in, that the public authorities fund are recorded on this GIS system. It's called Green City Clean Waters. But also, when individuals plant trees or when they create permeable pavements rather than impermeable pavements, where they transform their neighborhoods, this is also recorded. So what you've got is the positive interventions that are being made by the public authorities, and then this sort of citizen responsibility where they contribute to the bluing and greening of the city, to the stormwater resilience of a city. And you can see some examples here of what the city looks and feels like when you've got all of your citizens working with you, not just your authorities deciding what to do. Okay, I thought it might be useful also to share, Hong Kong suffers some real extreme weather. It's one of the most extreme places in the world that I've visited that suffers extreme weather. And what have they done? Well, they've gone for the sort of big grey solution. This is a huge tunnel. And this huge tunnel, plus the associated intakes, this collects the water, the storm water. And you get a sense of, if you've got $350 million to spend, maybe that's the sort of thing that you can do. But increasingly what we're finding is it's not enough. Either we can't afford the solely grey solution, or it's part of the solution where we think about what we can do with blue and green infrastructure. From our experience, blue and green infrastructure is a saving of about 35% against conventional grey infrastructure solutions. There's also other grey infrastructure that they have in Hong Kong, this idea of us building big concrete tanks, and it's great when you've got the space and it might be the base of a building and you can build up above it. So, yep, they've got one of these underneath Hong Kong Racecourse. I've been there. So let's just say we can do the grey bit, okay, tick, and I'm sure we've got a list of grey things we can do. But we can also start doing the green bit. So what I thought I might share is these are new developments, but they're not insignificant. This is for over 20,000 people. And what do those developments look like? Well, increasingly, a bit like the guide that you've got in your bags from Bydgoszcz, increasingly, these are about the sort of blue and green interventions you can make at a smaller scale, but we can do lots of them. And in doing that, that might significantly reduce the need for grey infrastructure. It's a sort of simple message. I'm not really trying to oversell it. But for me, it's something that means that we're working more in tune with our natural systems, and that's what we should be doing. Okay, so I've introduced this idea of things that we can do within the city space from a public or private perspective. But when we think about water resilience for cities, we think about shocks and we think about stresses. We can think about things like storms, or we can think about things like droughts or water stress. Or we could think about things like sea level rise being here in Gdansk, though I think the Baltic protects us a little. And so the sorts of shocks might be droughts, there might be floods. Now, flood is a great term that summarises lots of things. It could be a tidal flood, it could be an estuarial flood, it could be a fluvial flood, it could be a groundwater flood, it could be a pluvial flood, a stormwater flood. We can also get flooding through a sewage flood where we get combined systems, so we get public health issues. So flooding isn't just one thing. But these extremes of climate also can give us things that seriously can also, and this is quite a killer really, things like heat wave and things like thunderstorms. And what I've tried to do here is give you a list of the sorts of shocks that you might experience in a city. And the reason I've given you a suite of them is just be careful that you don't just go and solve just one shock and you leave yourself exposed to a whole load of others. So in Copenhagen, they had their cloudburst, their 1,000-year storm, which they responded to. It was about 600 million euros of damage. They've spent a plan of about 400 million euros to significantly reduce the subsequent damage from the same type of event. I think that's really significant that they reacted to one event with that sort of investment, but at the time haven't really spread that investment across a suite of risks, such as things like storm surge. So they're actually exposed to more frequent risks, but they've reacted to just the one that hit them. Stresses, which are things that aren't just that short, sharp shock, they're more incremental, are things like the southwest of the US have had in terms of regional water stress, or things like sea level rise, which although we may talk about sea level rise as being something somewhere off in the distance, what it does, it changes our base condition against which we can then have enhanced storm surge. So I think we should be very aware of how urgent these things are becoming. And things like changing rainfall patterns. And that's where I think an organisation like RETENCJAPL, who are starting to understand that from a Polish perspective with the Water Atlas, should start to look, I would suggest, at adjoining countries and get a wider database of our understanding of rainfall in this region. But you can see there's a whole range of stresses there that aren't just about climate. So when we start to classify these shocks and stresses, we can start to understand how they affect our cities. And this is the starting point to developing a resilience framework. We can then analyse them in terms of how severe they are in terms of impact, or in terms of how likely they are in terms of occurrence. So are they going to occur very frequently, and are they going to cause a big impact for us? This is why I'm saying we don't just respond to a single one. There's a whole range of things affecting our cities, our systems of systems, and we need a framework to understand that. So our approach to city water resilience is about looking at absorbing, adapting, responding and learning from shocks and stresses. We want to make sure we protect public health, the environment, and we want to minimise economic disruption. In some definitions of resilience, there's something about thriving as well, seeing the threat and see how we can rise above it. It's important that there are a catchment scale, that we adopt system of systems thinking, and that we have some element of maturity assessment. We've reviewed globally those tools, methodologies or frameworks that are in this space, and we think there's a sweet spot. That sweet spot is an approach that involves maturity assessment across a whole set of criteria for a city. But the important thing is, first of all, let's understand that system before we assess the resilience. If we assess the resilience, we can then look at a sort of gap analysis on what do we do to provide greater resilience. That provides a series of options to try and address that resilience that we can prioritise and then we can use for investment. We can monitor, take the feedback and use it as a process of continued learning. And we've invested about £1.5 million with the Rockefeller Foundation and Arup and Lloyd's Foundation, looking initially at 5 cities to do pilots and then extending to some what we call Wave 2 cities. These are cities experiencing real extremes, like Cape Town, like Miami, that dodged a 20-foot storm surge, like Mexico City, which is a great example of cities that experience all sorts of shocks, not just the shocks not just the water-related ones. Okay, so I thought I'd finish by sharing a little bit of the latest digital stuff. So the latest digital stuff for me is things like, how do we look at a city of 25 million people just using Google Maps and start to apply machine learning to Google Maps so we can start to understand the typologies in the city? So where is the porous space? Where is the green space? Where are the trees? Where's the blue space? And using machine learning, I think we've got about, against a trial, our initial approach is we've got about an 88% accuracy, and this is just our initial pilot. I don't know how drowned out that will come, but it gives you an idea of the sorts of things you can look at using machine learning. But we haven't just looked in the urban space, so I think that's something for from a stormwater perspective for you to think about maybe where's our first trial of machine learning in Poland, or are we already doing it? We might hear it shortly. But also in terms of how you look at natural flood management, which is increasingly within the rural space, important from a catchment perspective. Can we do something in the catchment that can benefit the city? That's really what the message is. Can we put small interventions within the catchment that can slow water down and help our city? So in conclusion, I'd like to thank you for listening. I'd like you to think about blue and green at a catchment scale, understand the governance, and think resilience, and think system of systems. Dziękuję.
Thank you.